Hello all, today in this video we are going to see an interesting topic. We are going to find out the structure for the metal clusters. Okay, it is also very simple as like borane. In the previous video we have seen how to find out the structure for borane, right? So closoborane, idoborane, arachnoborane, similar type of pattern, okay? It is very easier one. Okay, first of all, see this. If you are having n minus 1, it is supercloso, n plus 0, it is hypercloso, n plus 1, it is closo, n plus 2, it is nido, n plus 3, it is arachno, n plus 4, it is hypo, and n plus 5, it is known as clado. Okay, so what is n? You may have this doubt, right? So n is nothing but the number of atoms. Okay, number of metal atoms. Number of metal atoms, right? So I'm going to give you an example, okay, how to find out the metal clusters. See, first of all, what you should do is, suppose here I am having, okay, this is a metal cluster. Why it is known as cluster? Because the 4 or more metals are present, okay, hence it is known as metal clusters. It looks like a cluster, okay. See, in this case, you have to find out. In order to find out the structure, you have to find out the total valence electron count. Okay, first step. This is the first step. You have to find out the total valence electron. Then what you should do is you have to find out the poly electron count. Okay, poly electron count. Then you have to write it in the formula like n plus x. I will tell you what are these. Okay. See, you can take the simple example. This IR4CO12. Okay. In this case, you have to find out the total valence electron count. How can you find out the total valence electron count? See, here it is iridium 4CO12. So, what's the valence electron of iridium? Iridium comes under cobalt family, right? Hence, iridium will have a valence electron of 9. Okay? 9 into 4 plus 12 into 2. Because each carbonyl can donate 2 electrons, right? So 12 into 2, it is 24. Here it is 36. This is what is known as total valence electron count. Okay, total valence electron count. So this step is easy, right? Then in order to find out the poly electron count, what you should do is total electron count minus 12 into the number of metal atom present. Number of metal atom present divided by 2. Okay, so what's the formula? Poly electron count is equal to total electron count minus 12 into n divided by 2 is the formula to find out the poly electron count. Here we have total valence electron is 60, hence it is 60 minus 12 into n is the number of metal atoms. Here the number of metal atom is 4, hence it is 4 divided by 2. Okay, now 60 minus 48, it is 12. 12 divided by 2, it is 6. You have find out that the poly electron count is 6. Okay, 6. Now it is very simple. See the number of metal atom, it is 4. Okay, n, it is 4. N plus what will give you 6? N is nothing but 4, okay? N is number of metal atoms present, it is 4. 4 plus what will give you 6? It is 2, right? Hence, this in n plus 2 format, okay? N plus 2. So, here n plus 2 means it is nido, right? N plus 2 means nido. Hence, the structure of IR4CO12 is nido. Okay, this is how you have to find out. It is very simple. Okay, first of all, you have to find out the total valence electron count. For that, you have to take the valence electron of metal and the ligand. Okay, so after that, in order to find out the poly electron count, you have to subtract the total electron count minus 12 into the number of metal atoms present, okay, divided by 2. It will give you a number. You have to write it in the format n plus x, okay, because 6 means here 4 metals are present. So 4 plus 2 will give you 6, which means n plus 2 format. N plus 2 corresponds to nido structure. Hence this IR4CO12 belongs to nido. Okay, this is how you have to find out. So I think it is a easier topic, right? So we will try to solve the previous year questions now. Okay. Here the question is the cluster having arachnotype. Okay, the cluster having arachnotype. So you have to find out. What will you do? First of all, you have to find out the total valence electron count, right? Total valence electron count. See, for example, in this case, osmium 5 CO16. Okay, osmium 5 CO16. Osmium belongs to iron family. Iron will have a valence electron of 8, right? So 8 into 5 plus 2 into 16, which will give you 40 plus 32, it is 72. Okay, 72. This is what is total valence electron count. Okay, total valence electron count. So in order to find the Pauli electron count, what will you do? Total valence electron minus 12 into number of atoms. See the number of metal atoms, it is 5, right? So 5, okay, 5 divided by 2. 72 minus 60, which is 12 divided by 2, that will give you 6. Okay, 6. Metal is 5. So 5 plus 1 will give you 6, which means n plus 1. Okay, n plus 1. So n plus 1 means closer. Okay, closer. They have asked arachno, so this is not the right answer. Okay, that is wrong. So now, let us go for OS3CO12. Again, it is 8 into 3, 2 into 12, which gives rise to 24 plus 24, it is 48. Okay, 48 is the total valence electron count. In order to find out the Pauli electron count, it is 48 minus 12 into the number of metal atom present is 3, right? Divided by 2, which will give you 48 minus 36, right? 48 minus 36, 12 divided by 2, which is equal to 6. Here also 6. But the number of metal atom is 3, right? So 3 plus 3 will give you 6, which means n plus 3 format. Okay, n plus 3. N plus 3 means arachno, right? N plus 1 closo, n plus 2 nido, n plus 3 is arachno. So they have asked arachno, right? Hence this is the option. Okay, this will be the option. Okay, similarly I have already done this, right? IR for CO12 nido structure. Nido structure. So first one is closo, this one is arachno, this one is nido. Similarly, see here rhodium 6 into 9, it is 54 plus 32, it is 86. 86 total valence electron is 86 minus 12 into 6, it is 72, right? 72. So it will give you 14 divided by 2, 7. N plus 1, it is closo. This is also closo, right? This is closo. This is also closo. This is the only structure which has arachno. Okay, arachno type. Hence option B is the right answer. Okay, this is how you have to find out the structure. I think it is very easier topic. Okay, in organometallics, these are all the very simplest topic. See the second question, in a cluster H3CO Ru3CO12, total number of electrons considered to be involved in the formation is. So they are asking only total number of electrons. Okay, total number of electrons. No need to find out the structure and all. Just you can find out the number of valence electron. This is very simple one. Hydrogen will have a valence electron of 3, right? Because one hydrogen has a valence electron of 1. 3 hydrogen are there, so it is 3, right? So it is 3. For hydrogen it is 3. Then for cobalt it is 9. Ruthenium comes under iron family. Iron will have a valence electron of 8, right? So ruthenium will also have a valence electron of 8. So 8 into 3 it is 24, right? 24. Plus this carbonite, 12 into 2 it is 24. So this is 24 plus 24, 48 plus 9, 57 plus 3, it is 60. Hence this is the answer. See, these kind of questions are very easy. Don't leave these questions. The structure of boranes and these metal clusters, then term symbols, these are all very easier topic, right? Isolobal analogy. So you have to concentrate on these topics, okay? Now the third question is for you. Okay, third question is for you. This question is very simple one. Okay, so you have to find out the structure and share your answer in the comment section for this question, right? So what you should do, you have to find out the total electron count. Okay, first of all find out the total electron count, then Find out the polyelectron count. What will you do to get the polyelectron count? Total valence electron count minus 12 into the number of metal atoms present, okay, divided by 2. It will give you a number. You have to split that number, that is metal plus, see for example, if you are having x, x will be the answer. N plus what will gives the answer. So if you write in this pattern, n is nothing but the number of metal atoms, okay. So if you write this write in this pattern, then you will get the answer, okay. So try to find out the answer for this question. I am not going to give you the answer. You have to share your answer in the comment section. I will check it whether it is correct or not, okay. Now the last question, it is also a very simple one. Total number of vertices in metal clusters or these, okay. You have to find out the structure for these 3 compounds, okay, 3 metal clusters. Simple one. This is Ru6 carbon CO17. In all these cases they have given carbon also. Carbon has valence electron of 4, right? It is very simple. See, in this case it is Ru6 carbon carbonyl 17, right? So ruthenium has a valence electron of 8. So 6 into 8, it is 48, plus 1 carbon is there, then 17 carbonyl. So 17 into 22, right? 7 into 2. So 48 plus 4 plus 34 is 48 plus 4, it is 52. 52 plus 34, it is 86 is the total valence electron count, okay. Total valence electron count is 86. Now polyelectron count, if you have to find out, then 12 into the number of metal atoms, right? 12 into the number of metal atoms. Here it is 6. So 12 into 6, it is 72. Okay, 72. You have to subtract this. So we'll get the answer as 14 divided by 2, it is 7. Okay, 7. 7 is the answer, right? Here you are having the metal 6. So 6 plus 1 will give you 7. Hence, it is in n plus 1 format. N plus 1 means it is closure, right? Closure. N plus 1 means it is closure. So you can directly eliminate these 2 options, C and D. Okay, these 2 are not a correct one. So between this A and B, you can see both of them have nido structure. So no need to find out the structure. Some people always find out the structure for this too. In the option itself, they have given that in the both options, it is given as nido, right? No need to find out the structure for this compound. So simply you can go for the third compound, right? So this third metal cluster, see in this case, 5 ruthenium is present. Ruthenium has a valence electron of 8. 8 into 5 is 40. Then 1 carbon, for it is 4. Then 16 carbonyl, 16 into 2 it is 32. So 8 into 5 it is 40. Okay, 40 plus 4 it is 44. Then you are having 32. 44 and 32 it is 76, right? 76 is a total valence electron count, okay? Total valence electron count is 76, okay? Now you have to find out the polyelectron count. So it is very simple. 12 into the metal atom, it is 60. 12 5 is a 60, right? 12 into 5 is 60. So 76 minus 60 divided by 2. You will get the answer as 16 by 2, 8. Okay, 8. The metal atom present is only 5 and you are having 8. 5 plus 3 will give you 8, right? 5 plus 3 will give you 8. So it is n plus 3 format. N plus 3 means it is arachno, right? So hence this is the right answer, okay? Option B is the correct answer. This is the very easiest topic, okay? So don't leave this topic. You very easily you can find out the structure for the metal clusters, okay? First of all, you have to find out the total valence electron count. Then you have to find out the polyelectron count. And after finding the polyelectron count, it is very simple. See the number of metal atoms. So subtract the value, polyelectron count. Subtract the number of metal atoms from the polyelectron count, you will get the answer. Because see in this case, you are getting 8, right? So 8 minus the metal, 5. So will get us 3, right? 3 means it is arachno. This is how you have to find out the structure for these compounds. So I think we have done the previous year questions. This question is for you. You try to share your answers with me, okay, in the comment section. So I think this video will be helpful for you guys. If you find this video helpful, then kindly like and share with this with your friends, okay. Stay tuned. Thank you so much for watching.